Hello everyone, in today's video we're going to be taking a look at multi-dimensional lists in Python. Now one of the interesting things you probably noticed about lists in Python is we can make lists of just about anything. For example, if I say my list, I'll go old school C style here. I could do the number 5, I could come in here, I could say car, I could create myself a coordinate pair using a tuple, and of course I could also create a list. I'll do red and green. Let's be really naughty here. Whoops, that helps probably if you go ahead and create yourself a list that actually contains things that don't break Python. So what you can see here is my list has got a bunch of different junk in it. So we've got an integer, we've got strings, tuples, and another list. Wouldn't it be cool if we had the ability to reach into this list and get this value? So you're like, that's an interesting puzzle. Let's see what we got here. I'll say my list of, let's see, 0, 1, 2, 3. Oh, well, give me my list of 3. Okay, that gets me the list, but I need to get this one. I just want that one. What am I going to do here? I guess I could do, let's see here, item equals my list of 3, and then I guess I could say item equals my item of 1, and then I could print item. Let's see what that does here. We'll go ahead and run that. There we go. We were able to get that. So how did we do that? Well, what we did is we went into my list, we broke off this section, and then out of that new little list, we basically said, give me item 1, which would be the second item, of course, and then we printed it. Man, that's a lot of work. This is the long way. Let's do the short way. So what we can do here, too, is I can actually do something like this. Item equals my list of item 3, 0, 1, 2, 3, of 2. Actually, this would be 1 in our case. And if we print item, you will see that we have the ability to actually grab that second value out of this list in this list by basically doing a double index like we have here. Now you're sitting here going, oh, okay. That means hypothetically you could create a list that basically has 2 dimensions to it. Yes, another new dimension, new galaxy, intergalactic planetary. So let me go ahead and pause for a second here so I can build myself a nasty little collection of elements. So what I want to do is I want to have a list that I can access specific values inside my little nasty grid that I have right here. So the way we would do that is go ahead and I'll call it a grid, just to keep it simple for us, equals, create my list creator, and then simply I can throw in these items. Now, very sharp-eyed viewers will probably say, you should probably do this with tuples, but I'm going to do it with lists because I need to be able to change it. So I'm simply going to do that. I'll do 0, 1, I'll do 2, 3, I'll go ahead and do 4, 5. We'll put the 5 there. And then, of course, we'll do 6. Whoa, helps if you do it correctly. 6, 7, just like that. So what I have now is I have this represented in here by its actual value itself. Now, the cool thing is if I want to print grid element of 0, 2, I could simply say print 0, grid element of 0, 2. Now, if I were to run this, you'll notice that it's going to explode. Now, the reason it exploded is because each one of these pairs only has a 0 or a 1. So if I come in here and change this to a 1 and run that, you will notice that it grabs that value perfectly. It dives into this one, finds this guy, and then it grabs value 1, which by no staggering coincidence is a 1. Now, if I wanted to grab this 4, this would be 0, 1, 2. Element 0. I can just do that. 2, 0. Run it just like that, and you could see it would grab that element. Now you're sitting here going, oh, okay, that's not too bad. It's just, it's a list of lists is the best way to kind of think about it. Absolutely. Let's make a slightly more complicated example. Now we're getting a little more complicated. So what we have here is our little Minesweeper grid, which is actually a battleship grid. I should be more specific when I do these things. Battleship grid. And this is a little messy because we have a total of 4 rows here, but we also happen to have 5 columns. Oh, you can see where this gets a little tricky. So what is that going to look like? And is there going to be an easy way to sort of assemble this rather than have to have like a mile long of this grid statement? The answer is absolutely. Because if I take a battleship grid, and I initialize this as just an empty list, I can append that list with each one of my rows. So watch, I can come in here and say battleship.append, and then literally, because I am usually way too lazy for this, I won't be able to cheat like that. So we'll do an X, comma, and we'll do another X like that. So we'll come in here. Oh, whoa, 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 whoa. We're appending a list. Did you see what I almost did there? Oh, I almost goofed up so bad. Let's see here. We'll put an S. That will be our submarine X. And don't worry, I'll skip this part. Ah, there we go. That was a little easier. So you can see here, we basically recreated our little grid here in the same exact style that we had here, basically adding one of those elements onto it at a time. So now the cool thing here is that we can now play Battleship. So let's go ahead and ask the user for, we're going to use input here. We haven't talked about input, but we're going to do it anywhere. XY, let's go ahead and say, oh, that could be fun. How will we do that? We'd have to split the string. Yeah, let's do it that way. All right. So what I'm going to do here, as you can see me playing a little bit just to make sure it checks out, is I'm going to ask the user for their guess. Your guess, coordinate pair, separate by comma, and no spaces. Ah, that's very lazy on our part not to do all that work. Oh, we'll lower it and we'll strip it too, just in case, just in case. So if I would run this code real quick, it would say your guess. It would ask for something. I could type whatever I want in there because we haven't done anything. So what I'm going to do is I'm going to split my guess into two components. Guess one. Guess, actually we'll call it guess x. We'll make it nice and easy. Or if we want to be lazier, I'm just going to call it x equals guess dot split. And now what we're going to do is we're going to split it at the comma. And I'm going to ask for the first half of it. Now I'm going to get really, really messy here. And I'm actually going to convert that into an integer. Eek, this is dangerous programming here. So now I'm going to go ahead and do the same thing. I'll do guess.split, and I'll do a comma one more time. And of course, this time I want element 1, which is going to be to the right. This is going to be my y value. Now what we've done is we have ourselves a guess that's an xy. As a matter of fact, if we want to come down here and print xy, if I run my code, but do 3, 2 like that, you'll see that 2, 3, I should be more specific. You will see that it has no problem breaking that into its two separate components just there. It's basically chilling just like that. So now we're ready to reach into here and see what element is there. So now if I want to have some fun here, it says, oh, actually we'll be careful just for clarity. You guessed, just for clarity, x, comma, y again, just to make sure we're not goofing up too hard here. We're simply now going to say if. Now, how are we going to know if we get it? Pretty easy. We're going to go to the Battleship grid, give me x, give me y, and I'm going to say does not equal x. Now, you're sitting here going, what do you mean does not equal x? Well, if you look at my grid here, there's an awful lot of x's, and if it doesn't equal an x, that means we hit one of our ships here. Does not equal a print, we can now print hit. Now, if I come down here, and I can now say, obviously, if I didn't hit, I missed, else print sploosh. Missed. Nice. Let's try it out. Press my little run button at the top. Give my guess. So 1, 1. Enter. Kersploosh. Missed. Let's check that out here. Let's see here. 1 would be this one here, and a 1, 1. You can see would be this one here. No joy. Let's run that one again. Let's go ahead and say, let's see here. 1, 0. Hit. And you can see just like that, we're able to reach into that little grid there, determine if the thing is there, which it is in this case. We hit our carrier here. If we wanted to be a little bit more careful, we could say if this value equals C, then print you hit the carrier, and then we could change the value in here with a damaged hole. There's so many cool ways that you can use these two-dimensional lists for that particular point. Now, one of the things you have to be very mindful of these two-dimensional lists is you probably instantaneously said you could theoretically do a 15-dimensional list, and the answer is yeah. As a matter of fact, if you look at this list here, it's pretty complicated. It is a 2D list, but you can see how nasty this can get as you start adding lists to this list that's in this list. And it becomes very, very, very challenging to basically keep track of. And everybody's favorite AP test question, of course, is to flip these things around and invert them and sort them and randomize them just to make you miserable. One of the important things you have to remember with all of this is the amount of memory you are now sucking down. You want to be very kind of careful with that because separate. I will never spell that word correctly in my entire life. I'm not going to worry about it. So the important thing that we need to know here when you're working with them is just be mindful of your memory usage. This, for example, if I knew I wasn't going to change these values, I could have made them a tuple, which would have been a lot safer. I could have actually made just about all of this a tuple, which would have used a lot less memory, but then I wouldn't be able to change them. Enjoy.